Hi, welcome to today's talk about the 10 most common mycotoxins. During this video, you will learn how these fungal toxins affect our health and some evidence-based solutions that we can use to support their removal from the body once you see them on a lab test. My name is Dr. Giovanni Nelson. I'm a licensed practicing naturopathic physician, clinical nutrition professor, and co-founder of Healing Duo Integrative Family Medical Practice. So, what are mycotoxins and how do they ultimately affect our health? These days, most of our patients are more familiar than ever before with how fungi can interfere with human health due to the popular TV series The Last of Us. While there haven't been any strains known to be able to hijack our body like how it does in the show, or how certain strains of cordyceps can infect many bugs in the animal kingdom, fungi can still have a massive impact on our health through the mycotoxins they produce. Now, mycotoxins are a toxic compound. They're produced by a wide variety of different fungi, including several species of molds. These toxins can contaminate food, water, and even the air via spore contamination. Some common food sources include grains, nuts, spices, and dried fruits, but it can infect other things. Typically, contamination occurs before the harvest or during the storage when conditions tend to favor fungal growth the most. Now, these fungal spores are highly stable, and they can survive food processing, making them a persistent problem in food safety. The impact mycotoxins have on health can be severe and varied. Exposure to mycotoxins can lead to acute poisoning, with symptoms ranging from nausea and vomiting to severe abdominal pain and convulsions. Chronic exposure can lead to even more severe health issues, including immune suppression, growth impairment, and liver damage. Now, certain mycotoxins, such as aflatoxins, which we'll talk about a little bit more later, are potent carcinogens and have been linked to liver cancer. So let's just dive into talking about the different mycotoxins. Let's start with Ochratoxin A, and ultimately, where do we find it? This main species of fungi that produces ochratoxins tend to be the Penicillium species and the Aspergillus species. These two fungal species produce three types of ochratoxins, version A, B, or C. Ochratoxin A is the form that's most hazardous to humans. OTA, we'll call it OTA for short, this can be found in a wide variety of different wheats, fruits, oils, seeds, and in animal feed. And when we find it in animal feed, it actually ends up finding itself in things like milk, meat, and even in eggs, because it can be passed through due to bioaccumulation. Many foods and drinks, including wine, beer, coffee, tea, baked goods, meats, and dairy products, contain varying amounts of OTA. OTA has even been found in a wide variety of herbal medicines and food colorings and spices. There's even one source that I found that showed that it was even in some bottled waters. Inhalation exposure can occur. Typically, this happens in water-damaged buildings, so this also poses a significant risk. Let's talk about how ochratoxins affect those cellular systems. So basically the mechanism of action. OTA is an inhibitor of protein synthesis. Ultimately, what this means is that it blocks the ability of those proteins from being created and ultimately being able to function. In addition to blocking protein synthesis, this toxin has this ability to block the function of the enzyme phenylalanine hydroxylase. Sometimes places call it PAH. This catalyzes the transformation of the amino acid phenylalanine to tyrosine. Now, the amino acid tyrosine is very actively involved in the production of thyroid hormone, melanin, and catecholamines like dopamine, norepinephrine, and epinephrine. OTA can decrease the production of ATP, which is cellular energy. Mitochondrial dysfunction is often one of the first signs of OTA toxicity. OTA can damage the mitochondrial membrane and decrease the ability to transport electrons, which are necessary for oxidative phosphorylation. OTA can block gluconeogenesis from occurring. The process of gluconeogenesis is how you produce new glucose molecules during the fasting state, usually fasting, starvation, or low carbohydrate diets, and as well as intense exercise can lead to the process of gluconeogenesis being activated. OTA can also produce a wide variety of DNA mutations. Following bioactivation via the internal detoxification systems, OTA becomes more electrophilic. Now, after phase 1 detoxification via CYP450, OTA becomes a quinone, which can bind into DNA. Following exposure to cellular can become a phenoxyl radical, which can also bind to DNA. Glutathione may be able to take those phenoxyl radicals back to OTA. However, this process can lead to the production of superoxide free radicals, which can create this spiral of increased oxidative damage and the depletion of glutathione. I mentioned this term electrophilic before. Electrophilic compounds tend to be more carcinogenic because they can irreversibly bind to DNA and disrupt DNA function. OTA also can increase oxidative and nitrosative stress. OTA's presence can lead to the increased production of the following free radicals: the hydroxyl free radicals and peroxynitrite. Some other effects of OTA might include apoptosis, which is cellular death, and necrotic cellular death due to DNA damage, oxidative stress, and direct gene activation, which can shut certain functions down. Now, induced dysfunctions during cellular division can also occur due to the inhibition of histone acetylase transferase enzymes, or HATs. Now, HATs control gene function, DNA repair, and cell cycle control. So it's not something you want to lose control over. Ultimately, the health impact is some of the early onset symptoms that you can see include night sweats, heat intolerance, otitis media, which ear infections, conjunctivitis, dizziness, hear loss, fungal skin rashes, brain fog, some long-term issues, renal disease, including focal segmental glomerulosclerosis, immune suppression, neurodegeneration. Some places have shown that it might contribute to Alzheimer's and Parkinson's, as well as testicular cancer. Now, how do we treat this? Maybe we could look at some dietary things as well, but typically the first starting point, due to how much of an impact it has on detoxification, is NAC. See, NAC can block the cell cycle arrest that can occur due to OTA exposure, as well as free radical protection. Vitamin C, vitamin E, as well as vitamin A, they're able to remove free radicals via the electron transfer, which renders a lot of these free radicals harmless. Rosmarinic acid, which we find in rosemary, can protect liver cells and decrease the reactive oxygen species production. Silibin from milk thistle can decrease the cell death that we see in liver cells that are exposed to OTA. Quercetin is a nice addition. Quercetin supplementation can prevent cellular toxicity as well as apoptosis via the activation of the NRF2 pathway. See, this pathway is involved in detoxification, elimination of reactive oxygen species, which are ultimately free radicals, binds up and eliminates electrophiles, and has anti-inflammatory activity. Zinc and selenomethionine supplementation may help to resolve the depletion of OTA, the depletion that OTA normally causes. And during the acute exposure, you can use certain adsorbents to block the absorption of it in the GI tract. Things like activated charcoal, bentonite clay, chitosan, diatomaceous earth, glucomannan, humic acid, and prebiotics and probiotics. Specifically, you want to look at Saccharomyces boulardii and Saccharomyces cerevisiae, as well as zeolite. Zeolite also has some great adsorbent activity. So the next thing that we're going to talk about, let's talk about aflatoxin B1. Where do we find aflatoxin B1? Now, the only known species to produce aflatoxin is actually Aspergillus. There are about 18 different types of aflatoxins. 4 of them are more common in contaminated foods. The B1 or AFB1 is the most common type and the most potent mutagen, as well as being able to create carcinogenic activity. There's a B2 type, a G1, as well as a G2 type. But for the most of this conversation, we'll talk about B1. See, the reason why we're going to focus on B1 is because aflatoxin B1 is a known class 1 carcinogen. Ultimately, it means that it's known to cause cancer, according to the International Agency for Research on Cancer. Aflatoxins are known to contaminate corn, peanuts, wheat, barley, oil seeds and spices, as well as eggs, dairy products, and meat, since livestock often consume moldy feed. How does aflatoxin actually interfere with cellular function? So once ingested, the aflatoxin B1 is absorbed into the small intestines and then ultimately into the bloodstream. Once there, it's going to get transferred right over to the liver, where it's going to be metabolized by CYP450 enzymes in the liver, which is ultimately phase 1 liver detoxification. During this stage, aflatoxin is actually converted to a more toxic, highly reactive, very electrophilic version of the original. Now, this new B1 molecule has a high affinity for guanosine residues that are found on DNA, for which it binds to and then creates DNA mutations. It can also even bind to RNA and proteins, impairing protein synthesis and cellular function. Ingestion of aflatoxin B1 also produces free radicals, which cause oxidative DNA damage, lipid peroxidation, which ultimately destroys cell membrane function. What are some of the important health impacts, and what do we see clinically? So acute exposure to aflatoxin B1 can lead to vomiting, nausea, abdominal pain, as well as other signs of acute liver injury. This is mostly because the liver is the main target for this toxin. Over some long-term effects, we can see a 30-time increased risk of liver cancer, especially in those with hepatitis B viral infection, liver cirrhosis, immune suppression, stunted growth in children, cancer, chronic inflammation, nervous system degenerative disease. We can see teratogenic activity on pregnancy, as well as malnutrition due to its ability to block the absorption of vitamin A, C, E, and selenium. Now, what can we do with treatment, especially naturally? One of the most effective ways to reduce aflatoxin is actually through probiotic yeast and bacteria supplementation. The probiotics can bind aflatoxins in the GI tract and prevent their absorption. The best species, according to research, has shown that the Lactobacillus rhamnosus strain, typically the ones that are in live cultures from yogurt, showed about a 31% reduction in aflatoxin B1 binding, and Saccharomyces cerevisiae, also found in yogurt, also showed about a 30% reduction in aflatoxin B1. So that's a great place to start. Turmeric, which we find the active ingredient there is curcumin, has strong antioxidant activity and has the potential to decrease CYP enzyme activity, which can decrease the production of that more toxic version of aflatoxin B1. Resveratrol also contains potent antioxidant properties and can activate the sirtuin pathway, which ultimately increases internal antioxidant enzymes, superoxide dismutase, catalase, and glutathione peroxidase. Now, these enzyme antioxidants are some of the most potent ones that we have access to in our bodies, so we generally want to have those active, or at least the ability to turn them on. Another great place to go is selenomethionine. This may produce some kidney protection as well as some additional antioxidant support. Vitamin E is a superb antioxidant, as well as the only fat-soluble antioxidant we have access to that interfaces directly with free radicals. Fenugreek is a herb. This herbal supplementation has shown to be able to improve several kidney and liver function tests following aflatoxin B1 exposure. And during an acute exposure, so if you know someone's recently been exposed, again, there's adsorbents that we can use to block absorption in the GI tract: activated charcoal, bentonite clay, chitosan, diatomaceous earth, glucomannan, humic acid, zeolites, and those probiotics and prebiotics that we mentioned above. So what's next on the list? Trichothecene is the next one, and pretty much where do we find this one? Several species of fungi can produce the mycotoxin trichothecene, including Fusarium, Myrothecum, Stachyboris, and Trichothecum. Now, there are two general mycotoxins that are produced via trichothecene. You have the type A, which is foods commonly affected by this are barley, wheat, corn, oats, rice, and soybeans. And then the type B ones, which are mostly affect animal feeds. They're typically rapidly detoxified and eliminated, and so it makes it a limited concern in humans. Of the type A mycotoxins, we have the T2 and the HT2. They have higher toxicity compared to the type B versions. These mycotoxins may be absorbed topically, inhalation, and even orally. While they are a major problem in food production, water damage buildings may also cultivate the molds that produce this type of mycotoxin. So how does the trichothecene interfere with the cellular function? These toxins can affect the central nervous system. They can affect the GI tract, skin, immune system, and liver and kidneys. Once in the body, these toxins can block protein synthesis. They definitely cause oxidative damage and block DNA expression, ultimately resulting in cellular death. The target cell for these mycotoxins, however, are rapidly developing tissues. So these particular mycotoxins are an issue for younger children, so keep an eye on that. Now, what's the health impact and clinical importance? During acute exposure, you can see some common symptoms like lethargy, ataxia, abdominal pain, nausea, vomiting, the classic, loss of appetite, some as well as some neuroendocrine changes. Some long-term effects include growth retardation, immune suppression, bone marrow dysfunction, allergies, secondary infections, skin issues similar to what you would see with like radiation damage, and that can range from redness to necrosis. So it's definitely important to keep an eye on almost like a nutritional physical exam where you're examining the total person. What are some treatment options that we can use naturally? Now, you want to focus on antioxidant protection here. Vitamins A, E, and C, they've been known to decrease lipid peroxidation that's caused by those free radical damage that we mentioned. I've seen in a recent study that quercetin might not be able to compact the mycotoxin directly here, but it can still support the total antioxidant or the total body antioxidant status and increase the activity of the internal free radical scavengers, superoxide dismutase, as well as glutathione peroxidase. Selenium could be a great and effective antioxidant here to help to counter the immunotoxic effects of the mycotoxin. NAC, just like before, the supplementation of NAC can help to decrease the amount of reactive oxygen species as well as the malonyl dialdehyde production, which it tends to increase during toxin exposure. Typically, NAC will also increase the internal antioxidants catalase and superoxide dismutase. Malonyl dialdehyde is an organic marker of oxidative stress as well. So fish oil supplementation might actually work really well here. So omega-3 polyunsaturated fatty acids have been known to be an anti-inflammatory agent, effectively blocking interleukin-6 inflammatory cytokine expression. Sea buckthorn may also be able to help protect against the immunosuppressive effects of the T2 toxin, and seems to be work even better, have increased synergy when it's combined with glucomannan. Now, during the acute exposure, you can still use some adsorbents to see if you can block the absorption in the GI tract. There's a little bit different ones here, but activated charcoal, bentonite clay, chitosan, glucomannan, and probiotics like Saccharomyces boulardii and the lactobacillus species may be more beneficial, as well as some zeolites. Now, the next up on the list is zearalenone. And where do we find zearalenone? The only known species here that produces zearalenone belongs to the Fusarium genus. Now, zearalenone is an interesting mycotoxin because it's actually a non-steroidal estrogenic mycotoxin. And this mycotoxin is frequently present in wheat, oats, barley, corn, sorghum, rye, rice, a lot of the grains, sesame seeds, malt, soybean, as well as milk and beer. Now, this mycotoxin is actually named for its consistent presence on corn, which is also known as zeamate, and its chemical structure contains a lactone ring, which also contributes to its name. Now, interferes with cellular function in a little bit of a different way. This mycotoxin is immunotoxic, hepatotoxic, and also expresses some xenogenic effects as a xenoestrogen with anabolic activity. Once ingested, the mycotoxin is rapidly absorbed into the intestinal tract. During phase 1 detoxification, the mycotoxin is metabolized into an alpha and beta compound in the liver cells via CYP450 enzymes. The alpha compound is the star of the show. It has a really high affinity for estrogen receptors and is significantly more toxic than the original form. Now, the beta compound is essentially harmless. Granted, we don't want it in our bodies, but it's not as bad as the alpha form. So the health impacts and some clinical symptoms typically are during acute exposure, you can see premature puberty, you can see hormonal dysfunction in both males and females. And so you'll notice that hormones and hormone function tend to be the main issue with this mycotoxin. Long-term effects lead to infertility, reduced fertility. We see feminization in males, which is testicular atrophy. We'll see decreased milk production once after the birth. And you'll see also cancer, different type of hormonal sensitive cancers, ovarian, cervical, prostate, as well as breast cancer. So this is a good one to pay attention to. What are some things we can do treatment-wise? Quercetin can decrease the cellular injury that you'll see from zearalenone exposure by that NRF2 signaling pathway that we discussed earlier before. Other than that, there's not really much that we can do other than avoiding the exposure of this mycotoxin. Now, I didn't mention it before, but this goes for all fungal mycotoxin. The best course of action is generally to avoid it. During acute exposure, you can try to use some adsorbents to block absorption in the GI tract. The issue is that these solutions actually are really important because this mycotoxin has the ability to undergo enterohepatic reabsorption. During phase 2 liver detoxification, specifically glucuronidation, makes this mycotoxin more absorbable in the small intestines. So it causes it to stay in the body longer. It just keeps getting recycled and deactivated and recycled. Typically, the adsorbents are activated charcoal, bentonite clay, chitosan, cholestyramine actually, prescription, diatomaceous earth, glucomannan, humic acid, as well as some probiotics and prebiotics, typically the Bacillus species and the Lactobacillus species, Saccharomyces cerevisiae, and zeolite. The next one that we're going to talk about is the Chaetoglobosin A. Now, this comes from the Chaetomomum globosum fungus. It's typically more found in water-damaged buildings. About 50% of water-damaged buildings have this microbe growing in it. There are not a lot of studies actually on this mycotoxin, but what we've seen so far is that even a small amount of exposure to cells is lethal. And there's a strong possibility that this mycotoxin may be the causative agent in sick building syndrome. So how does this mycotoxin interfere with cellular function? Once in the body, the mycotoxin binds to actin, which is an important filamentous protein that aids in the movement of important structures inside of the cell. The loss of actin blocks cellular division and movement of important cellular proteins. This is also really important because the actin plays a role in the ability to insert cell surface proteins, and so that it's cellular communication with one another. Now, how does it show up clinically, and what are some of the acute symptoms? Acutely, you'll see asthma, typically in children, irritation of the eyes, nose, and throat. You see some dry skin, dizziness, nausea, headaches, hoarseness, wheezing, and increased susceptibility to upper respiratory tract infections. Some of the long-term effects are neurotoxicity, immunosuppression, and ultimately death. Now, how can we treat this? This is a hard one because the treatment here, again, is mostly going to be avoidance. You can consider some of the detoxification strategies that we talked about earlier in typically boosting antioxidant support, but I haven't been able to find any specific studies on that. And so it's more of just like how do you support the symptoms at this point? The next one on the list is citrinin. Now, citrinin is an interesting one. It's actually the second most commonly reported mycotoxin that we see on lab tests, and it's usually seen reported concomitantly with Ochratoxin on results. Now, this is usually because it's produced by Aspergillus and Penicillium fungi, which Ochratoxin also produce or come from. This mycotoxin is also known to come from the Monascus purpura yeast, which is the red yeast rice. Now, this mycotoxin is also produced by the Monascus purpureus yeast, and this is known as the popular red yeast rice supplement. This supplement has a statin-like activity, which the active ingredient is monocolin K. These days, all the red yeast rice products are screened to ensure that the citrinin levels are acceptable. But if you see elevation on citrinin in a lab test and you can't find any other source of exposure, I would use caution and just double check to make sure that the person is using a good quality red yeast rice supplement, especially if it's on their supplement list. This mycotoxin does affect other commonly ingested foods like rice, oats, corn, wheat, rye, barley, as well as some naturally fermented sausages from Italy. You'll see some vegetarian foods that are colored with the Monascus pigment also commonly affected by this as well. So how does citrinin affect the cellular function? Now, this mycotoxin seems to work in two different ways. The first one is that it decreases enzymatic activity throughout the body, as well as increased production of oxidative stress. Once ingested, the mycotoxin boosts the production of superoxide free radicals and other reactive oxygen species. This increase in production of free radicals tends to explain the mitochondrial dysfunction and lipid peroxidation, as well as cell death that's often seen. Now, what are some of the clinical symptoms? What do we see clinically in the health impacts wise? Generally, acute symptoms, we tend not to see many with this mycotoxin. It tends to be very rare. You see some long-term dysfunctions, and long-term effects are liver dysfunction, kidney dysfunction, and the kidneys here are actually the major target organ, so keep an eye on those, and some bone marrow dysfunction as well. Cancer, typically kidney and testicular, lots of oxidative DNA damage, and it's mutagenic, as well as nephrogenic diabetes insipidus, because of its, again, being the target focus is the kidneys. Treatment-wise, the main thing that we've been able to see in the studies and literature is the mannan oligosaccharides. This prebiotic has been shown to bind citrin, especially in the GI tract, and this product is actually produced from the outer wall of the Saccharomyces cerevisiae probiotic, and it's marketed as glucomannan in a soluble form. So the next one we'll talk about is Enniatin B. Now, this mycotoxin is produced by the Fusarium species of fungi as well. Cereal grains are the most commonly contaminated. It can be found in fish, nuts, spices, dried fruit, cocoa, and coffee. This particular mycotoxin can interfere with cellular function, and it's a little bit different in the way that it works. See, Enniatin B is a fat-soluble mycotoxin. This allows it to create a positive ion selective pores throughout cell membranes, especially in the mitochondria. This results in severe physiological disturbances in the cell, as well as possible cytokines. Some studies haven't been able to show this toxicity in vivo, so in the actual live studies, but we've seen a lot of it when you see the in vitro studies. Some clinical symptoms typically include, after an acute exposure, you're going to see fatigue. Fatigue is the standout symptom here because this mycotoxin essentially just pokes holes throughout the mitochondrial membrane, which ultimately destabilizes the electrical potential required for oxidative phosphorylation to work and create ATP, which is cellular energy. Some long-term effects we'll see is some weight loss, as well as liver disease. Treatment here, generally, this is another one we want to just avoid. The treatment is avoidance. If you see it on a test, try and find the food source that the person's ingesting consistently and try and remove it. You can consider some detoxification and antioxidant support as well, but I would keep it more specific to the symptoms that the individual is having. If fatigue is the main problem, support the fatigue. What about gliotoxin? Where do we find this one? So this mycotoxin is found specifically in the Aspergillus fumigatus fungus. It's also found sometimes in Penicillium and the Alternia species, but more commonly the Aspergillus. Now, gliotoxin exposure can come from contaminated food and buildings that have undergone water damage. Common foodstuffs include rice, barley, wheat, hazelnuts, walnuts, peanuts, cocoa, and coffee. The gliotoxins interfere with cellular function by, once it's inside of the body, they start to produce a massive generation of reactive oxygen species. This can inhibit phagocytosis in white blood cells. It can block the NF-kappa beta pathway, which is essentially inhibiting the inflammatory response required, as well as increase cytokine production, and it can disrupt mast cell degranulation. The toxin also stimulates apoptotic pathway in monocytes and macrophages, which further suppress immune function. The important clinical symptoms, and you can imagine based off of how it interacts cellularly, is during acute exposure, you'll see frequent infections, typically the upper respiratory tract, but you can also see some GI tract infections. And during long-term exposure, you can see some immune suppression. You can also see some neuroinflammation. Some studies have shown that it may worsen or even initiate the onset of multiple sclerosis. Now, how do we treat this one? This is another one that we want to try and focus on avoidance. You can see, and I've seen some studies that shown that some of the binders that work for Ochratoxin might also be beneficial here, but I couldn't find any specific literature to support any specific agents. Now, let's talk about the best known mycotoxin, mycophenolic acid. Where do we find mycophenolic acid? This mycotoxin is produced by various fungi in the Penicillium species. It is one of the best understood mycotoxins due to its use as a pharmaceutical agent. The mycophenolate mofetil is a first-line immunosuppressive agent used in transplant medicine and in rheumatological cases of lupus nephritis. Mycophenolic acid exposure often occurs in office buildings, believe it or not, through air supply via inhalation. You can find mycophenolic acid in foods like corn, rice, cheese, jams, and bottled waters. Now, you can imagine by how it works as a drug, cellular function-wise, it interferes with a specific enzyme. So mycophenolic selectively inhibits the enzyme inosine monophosphate dehydrogenase. Now, that mouthful basically is just for the enzyme specifically responsible for the de novo synthesis of guanosine nucleotides inside of the lymphocytes. And it's actually the only pathway to support purine synthesis in both T and B lymphocytes. Ultimately, shutting down this enzyme turns the B and T cell proliferation off and decreases its ability to do that, which is essentially why you get the immune suppression. What are some of the health impacts? Again, as you can guess by how it works, acute exposure can lead to immune suppression, and long-term effects, typically if you take the exposure for the compound for too long, it can lead to cancer due to the downregulated immune response. What's the treatment here? Just like the other ones before this, the main focus is avoidance. There's not any specific things that I found in the literature that showed that it could help. However, ochratoxin the things that worked in terms of binding for ochratoxins might have some benefit here. There's no specific agents. Now, last but most certainly not least, we're going to talk about the mycotoxin Sterigmatocystin. Sterigmatocystin is known to produce from a species of Aspergillus. Other species can produce the toxin as well, typically the Cladosporium, Fusarium, Penicillium, Stachybotrys, as well as the Trichoderma. Now, this mycotoxin, as you'll notice, is similar to some of the ones that we talked about, at least who produce it earlier. And it's actually a precursor to the Aflatoxin B1, which tend to show both of the mycotoxins present at the same time on a lab test. However, unlike its cousin molecule, the Sterigmatocystin, it's a class 2B carcinogen, which means it's only possibly could cause cancer in humans. And this is according to the International Agency for Research on Cancer as well. It's commonly found in cereal grains, corn, rice, coffee, spices, beer, and cheese. Damp buildings and indoor dust may also contain significant amounts of the mycotoxin, which can lead to inhalation exposure. How Sterigmatocystin affects cellular function is that once in the body, the mycotoxin gets metabolized by the CYP450 enzymes in the liver and lungs, and this produces a more reactive compound. If you can tell, that's the name of the game with liver detoxification. This compound, it rapidly increases reactive oxygen species, ultimately overwhelming internal enzyme antioxidant systems, catalase, glutathione peroxidase, as well as superoxide dismutase. The mycotoxin then induces cell death, mitochondrial dysfunction, DNA damage, and cell cycle arrest at the G2 phase. Now, the G2 phase is a period of rapid cell growth and protein synthesis. And this makes the cell basically where it prepares itself for mitosis, so almost everything is doubled. This Sterigmatocystin mycotoxin also undergoes enterohepatic recirculation via the bile, so it creates this lingering effect where the toxin stays in the body much longer because it's consistently being reabsorbed in the GI tract. So some clinical symptoms and some common health things that we'll see here are after acute exposure, you'll see some fatigue, diarrhea, and nausea. And the long-term effects are liver toxicity, kidney toxicity, typically affecting the liver and gastric systems, and immunosuppression as well. Treatment-wise, luckily we do have some supportive agents that we can use. Again, seems like the superstar of this lecture. NAC supplementation can protect against free radical damage. Recall that when we use NAC, it will increase the internal antioxidant systems, the enzyme ones particularly, catalase and superoxide dismutase in this case. Another unique one is red pomegranate peel extract. This provides high quality polyphenols and flavonoids that have potent antioxidant activity, and the quercetin has immunomodulatory activity as well as antioxidant activity, which can be very cytoprotective. During acute exposure, you can use one of the adsorbents to block its absorption in the GI tract, which is bentonite clay. So just kind of to go over everything and bring it all together. Mycotoxins are potent toxins. They're produced by fungi. They're commonly found contaminating food, water, and air. They generally pose significant risks to human health, including acute poisoning, all the way to chronic conditions like cancer and immune suppression. Recognizing the sources and effects of mycotoxins are essential for early diagnosis and treatment. Awareness is critical, especially in the healthcare setting, to address and effectively fix these toxins and remove them from the body. Now, I didn't really stress it early on, but the best treatment overall is prevention. Typically, when dealing with toxicants in environmental medicine, prevention is the most important approach. It's difficult to treat someone if they're constantly still being exposed to the thing that you're trying to remove. So removal of exposure is paramount to the success of any treatment plan. You can consider some of the dietary adjustments and herbal protocols that I mentioned earlier up above, especially based specifically on those mycotoxins that are present. Specific adsorbents that were mentioned, like activated charcoal, bentonite clay, and zeolites, may be helpful in binding mycotoxins and reducing their absorption if exposed via food. And supplementation with compounds like NAC, minerals, and probiotics can be used to support the detoxification pathways as well as modulate immune function. Use of vitamins A, C, and E, as well as some polyphenols and flavonoids, might be beneficial in recharging the internal antioxidant systems, activating free radical scavenging systems that are supposed to be on in the body. If you're having any patients experiencing any immune, neurological, gastrointestinal, skin dysfunctions, please consider mycotoxin exposure in your differential diagnosis. A well-placed mycotoxin test might help to pinpoint the potential cause of your patient's or client's health concern. So thank you so much for joining me today. I hope this review of mycotoxins was helpful. I do look forward to seeing you at the next video. Thanks.
Welcome to Rupa Health, the best place to order, manage, and track results from over 30 different lab companies in one single place for free. It's going to take you under 2 minutes to sign up, and you can order any functional medicine lab for your client in under 30 seconds. Let me show you how it's done. So here's our beautiful interface. I'm typing in the name of my client, selecting the lab that I want to order for them, and hitting send. From there, Rupa and their amazing team handle the rest. They email the client, collect payment, and even offer an interest-free 3-month payment plan. We've also built the world's largest library of information about chronic health conditions, the lab tests that can help you find the root cause, and the evidence-based interventions that you can use to help people heal from them. It's called the Rupa Health Magazine. There, we have in-depth articles about almost any health condition you can imagine. And we give you step-by-step protocols that other clinicians have used to help their clients heal and that are verified by evidence-based sources. You should totally check it out, and it'll transform your practice. And we can't wait to see you. So make sure you sign up today at rupahealth.com.